We might as well go ahead and get started and make good use of the time we have here. Before I begin, I hope those of you here in the room were able to attend the previous talk. I actually thought it was an excellent talk about a journey of one company going from running their own infrastructure, their own software, moving over to managed services, to moving over to serverless computing. And it's also a wonderful product. I was actually elated. We have Comcast X1 throughout our house. I was actually elated to find out that that was actually using Kinesis technology, because it's a great experience. I live in a house with 2 daughters and a wife. When I'd go home and eat, there's no chance I'd ever get to watch the TV. It would all be blocked up. And that device has changed my life, and it's actually great to see how it's taking advantage of cloud services. So good afternoon, everyone. I'm Roger Barget. I'm General Manager of AWS Kinesis. I'm here with my colleague today, Ryan Enice, Product Manager for Kinesis Analytics. On behalf of the entire Kinesis Analytics team, it's our pleasure to introduce you to Kinesis Analytics today. I'm going to be saying a few opening remarks, just trying to frame why we've built this service, how it fits in with the services we have today, and directionally where we're headed with this. One observation that we've made is that most data today is actually generated continuously. And with the rise of devices, this data is now coming at us at lightning speeds and massive quantities. And in fact, we believe that this is just the tipping point. This is just the beginning. Again, most data is generated continuously. And this data actually has valuable information in it if you can convert it from raw data to information in a timely manner. And regardless of whether it's something from a mobile app, web click streams, smart building, IoT sensors, media records, metering records, consumer interactions with your services, monitoring your devices, there is valuable information. And if, for those of you who have been watching talks about Kinesis and real-time analytics, and if you look at the companies that are actually using it today, these companies lean in very far forward, embracing new technologies. They roll up their sleeves and they build very complex applications. That's the narrow few. What happens when this technology becomes democratized? What happens when it becomes easier to use? What's going to happen in the world we live in, and how fast we're able to get insights out of our data? Another observation is, what is your data worth? Well, there's really a diminishing value of data. If you look at the value we extract out of data today, that data is days, weeks old, and we still get incredible value out of it. But as you move closer to the real time, you can get these valuable insights out of data. Mike Gilitaria of Forrester has a beautiful phrase for this in a wonderful series of talks I'd encourage you to look at. He calls these perishable insights because that value diminishes rapidly. If you're looking at a transaction, is it fraudulent? Yes or no? Do we have systems to do that today? Absolutely, because of the money that's on the line. But again, it's the few that can actually implement these. Think of all the other cases when you're looking at a customer. Should I sell them an ad? Should I give them this offer? Are they near my store? If you begin to think about the myriad of applications that are untapped today, where there's perishable insights on the line. Another observation is that data becomes even more valuable when you can combine the recent data with the old data. How are my sales trending relative to last week? Are my customers and the cohorts that are my customers, are they changing relative to last week? And if so, is this in response to basically the ad that I just ran? Once again, an example of not only is fresh data highly valuable, but if I have the means to combine it with my old data in near real time and make decisions in real time and do it in a way that anybody can implement the application, there's incredible value to deliver to customers. And this has been the journey that we have been on. And again, an observation that you can make, very few companies have been able to take advantage of this. Why? It requires programmers and developers with very special skills, the ability to write programs that can process this data, extract information out of it in near real time, pump it to a system where a decision maker can then make a decision on this. And oh, by the way, you then have to actually manage a fleet of machines to run these applications. You have to scale it as your business runs. This has been the problem that we have been looking at as a team now for several years and trying to incrementally chink away at it. And again, I want to make sure you leave today understanding how this new service fits into this repertoire of services that we have been building. So what are some of the key requirements? And this is a deliberately crufty slide. We didn't want to go too much into it. We'll talk more about it later. But it really is a pipeline of steps that you have to be able to support, all the way from data ingest. And that data ingest has to be durable. You may have applications that start up a few minutes after others. You may have multiple applications analyzing all the streaming data coming from these myriad of devices, from mobile, consumer online, cash registers, beacons, and more in the future. You need to be able to ingest that data and capture it in a durable and scalable manner. Scalable is key here because the workloads will vary throughout the day. You have to have the means to transform it. And not just a single transform, it could be multiple transforms depending on who's actually going to be using that data. So that's a second important step that you have to support in the pipeline. You have to analyze it. And again, if that analysis means writing some very crufty program, a very special program, that's again going to actually winnow down the people that can actually use it. You'd like to expose something like SQL that most people understand, most developers can get their head around and immediately write code to actually then to analyze it. And then once you've analyzed it, you need to react. Send it to some system that can tell somebody, here's a decision that has to be made, here's an opportunity that you can actually capitalize on, and then persist it, again, maybe for historical analysis, and that end-to-end pipeline has to run in less than a second or two. That's what we're trying to go after. That's how you move companies into the real time and allow you to really get that perishable insight out of the data. Only other thing I'd say about that, oops, switched on that, is that it also has to basically be correct. This pipeline has to ensure that each and every record gets processed, nothing gets skipped. Reactive, reliable, there's a number of IDs that you have to tack onto this to make this whole thing work end to end. But this pipeline, let's transition a little bit into basically looking at what we've been looking at in terms of Kinesis. Now, if you're here in the previous session, you saw descriptions of these. I'll talk about it briefly, but I'd like for you to be thinking about that pipeline that I showed you and how each one of our services compose. And again, I'll make a statement here. We've been building the Kinesis services, which today consists of Kinesis Streams, Firehose, and today Kinesis Analytics. Each one is independent, provides independent value, but they are designed and intended to be composed to actually build these end-to-end pipelines. And should you want to swap out another service, such as Kafka for the ingest, Firehose and Kinesis Analytics will allow you to do that over time. These are meant to be composable. But streams. It is our durable data and scalable data ingest. You think about what your capacity is, what your data rates are going to be coming in. You create the stream with the necessary number of shards. If you get throttled, you'll be able to scale up, scale down your stream dynamically. That is your durable record of your streaming data coming in. For 24 hours, it can be extended out to 7 days. And again, a lot of our customers, highly technical customers that lean in, were using the KCL to write real-time processing applications with 20 millisecond response time for real-time bidding. We're trying to actually say, how do we bring that kind of capability to a broader audience? And the second one, we talked about it in the pipeline. You have to be able to deliver this data to make a decision, to load a dashboard. Think about now the role Firehose plays. Kinesis Firehose does delivery of streaming data from sources. We have the Kinesis agent, it has an API. You put your data into a Kinesis Firehose. You don't worry about the scale. We scale it for you. You can tell us to encrypt it, to batch it, and what period in which to load it. And you choose the destinations, which today is S3, Redshift, Elasticsearch. And yes, you can imagine that list is going to be growing. Every time we meet, we'll be talking about a new destination we can share with you. But not only does this give us an easy way of delivering streaming data into AWS services, where a lot of our customers were already running their business, had their Tableau dashboard hooked up to Redshift, but think about what in the context if you were doing stream processing and cooking data, looking at outliers, doing aggregates, and doing, looking for insights. Feed it to Firehose, bam, immediately your Tableau dashboard lights up with the insight. And here's our addition today, Kinesis Analytics. Ryan will be taking you on a tour of Kinesis Analytics. As you heard before, under the covers, it is a real-time streaming SQL engine that runs basically in sub-second processing time. You have full ANSI standard SQL, which has been extended with this notion of windowing. Why? Because you don't have tables. You have streams, which are infinitely unbounded. And some of the nice things about the service, and you'll see it in the demonstration or later today, Kinesis Analytics will look at your stream. It will actually propose a schema for you, allow you to drop columns, allow you to name columns, change the type if we got the type inference wrong, but we schematize your streams, your records in your stream. And we have effectively then turned it into a table which is unbounded because data can continue to come in. Once we've done that, we allow you to write SQL and chain your SQL. I have seen very complex analytics applications written in standard SQL. But we want to go beyond that. When you look at the service, you'll see that we have been putting in some streaming analytics algorithms, including anomaly detection, which has a novel and published machine learning algorithm. And you'll see more appearing as well, because not everything fits in SQL. It'd be kind of nice to have some very advanced analytics specific to streaming inside the service. And so we'll be doing more there. And it scales. It will look at the incoming rate of your stream. It will look at the complexities of the query, the amount of CPU you need to keep up, the amount of memory you need for your windowed queries, and it will scale the amount of resources dedicated to your service. And as your stream dies down, as the queries shut down, it will collapse and your costs will reduce. So it dynamically scales with exactly what you use. Now, if you just pause for a second and think about that pipeline that I actually started with, and think about how our service is now composed. I can take a Kinesis stream if I actually want to use that as my ingest. Firehose is also an ingest. Kinesis Analytics can connect to both of these services as its input source. The analytics can do the necessary processing to extract the insights from the data, create an alert, pull out some computed aggregate, maybe compare it with historical analysis, like our sales today are 20% lower than they were for the last month. You might want to let something know. We monitor that at Amazon. If the market basket or the amount of goods sold dropped by some percentage, we think there might be something of interest here. Now remember, you've got a Kinesis stream which has 24 hours of data. How cool would that be to pose a query over what happened in the last 24 hours? Again, that's the value of having that durable, scalable ingest stream coming in to the analytics. And then once the analytics has been computed, you can deliver it straight to Firehose, which would then load Redshift or a Tableau or some other user experience. It can load S3, it can load Elasticsearch, or you can put your resulting data in a Kinesis stream and have a Lambda function. And yes, we'll be looking for more integration points for Kinesis Analytics to send for notifications for other dashboards. So this is how we've been thinking about this broader problem, the challenges, what we're trying to enable to allow you to get perishable insights in real time. And again, I'll argue a lot of batch processing jobs today, if you look and say, where did this data come from? It was continuously generated data. The users would have loved to have had instant insights out of that data, but the only means they had was actually MapReduce and Hadoop jobs. We're trying to bring a set of services together which compose and actually allow you, our customers, to get real-time insights and then compose the services the way you want to actually build the actual application that you want over your real-time data. So with that, I'm going to turn it over to Ryan Nienhuis, who's going to take you on a deeper dive through Kinesis Analytics.
Thanks, Juan. Thank you. Hi, everyone. My name is Ryan Nienhuis. I'm the product manager for Amazon Kinesis Analytics. I'm very excited to talk to you today about the service that we just launched and how it fits into you building your real-time streaming processing applications. So what are the most important aspects of what we've built and offered to you today? So one of the biggest things you'll notice, especially as I go through sort of a video demo at the end of the presentation, is that the service is very, very easy to use. It allows you to connect to your streaming data sources, schematize and structure that data, expose it to your SQL code, and allow you to run that SQL code in minutes. It gives you instant visibility into what's going on in the stream with real-time data processing. It's very elastic. It will scale to handle both your query complexity and your streaming data throughput. We offer sub-second processing latencies for many queries. And it's standard SQL. So as Roger mentioned, we've implemented ANSI SQL. So we're presenting you with a very familiar data manipulation language in order to process your data. So what do you do with Kinesis Analytics? With Kinesis Analytics, you build streaming applications that will continuously read from a streaming data source, process that data using your configured application code, and emit that data to a configured destination of your choice. So we support, for each one of your applications, we support connecting to a single streaming data source, either an Amazon Kinesis Firehose delivery stream or an Amazon Kinesis stream. And the way you'll make a decision about which ingestion stream to use is if you want the raw data sent to S3 or Redshift or Elasticsearch, you'll use Firehose. If you want to build custom applications and want some more flexibility with what you're doing with your stream, you'll use Kinesis streams. We support JSON, CSV, variable column, and unstructured text. So you can even bring in things like Apache logs into your Kinesis Analytics application, structure them, and run standard SQL on them. Each input has a schema. And as I'll show this in the video, but basically we'll sample records off your stream, and we go through a process called discovery, in which we do schema inference. It's backed by an API, and we present that recommended schema back to you. Now, we don't think we're going to get this perfectly right for everyone, so we view it sort of as like, we'll get it there 90% of the way, or 95% of the way. And then we give you full flexibility to edit that schema. So if you may want to loosen the restrictions on some columns, maybe you have an upcoming schema change and you need to add a couple more columns that are not there yet, that type of thing, we give you that flexibility to do so. And you'll notice in the experience that theme is present throughout, where we're going to help you get started very quickly and then provide you the flexibility to run with it, to build the application to meet your use case. We also support another type of data source called the reference data source. Reference data source is different than a streaming data source in the fact that we will continuously reading data from that streaming data source. So we're always reading from the stream to grab new data to feed to your SQL queries. A reference data source, we are going to read at periodic intervals and pull it entirely into memory and represent it as a SQL table. The primary use case for this is to do data enrichment. So if you have a unique identifier coming in on your stream, you've got some metadata that you want to attach to that stream, say before you emit the data to Redshift, reference data sources allow you to do that. So what does your application code look like? So we present your streaming data source after the schema is applied in what's called an in-application stream. This in-application stream looks very similar to a table in which you select from in your from clause of your SQL statements. From there, we have very robust SQL support, everything from simple mathematical operators to powerful string manipulation functions like regex matching, log parsing, that type of thing. And also advanced analytics. So Roger mentioned we have an anomaly detection algorithm we ship with that's exposed to you in your SQL code. We also have approximate distinct items, which we've implemented hyperlog log, and several other algorithms that are available to you. And I think we've just gotten started there, and we'll continue to add them over time. What we hope to do is that for you all to try the service and give us feedback about these are the functions that we want. Even further, we look to extend the functionality beyond that over time. So there are some extensions that I'll cover in a couple of slides later that we've made it easier to write standard SQL over streaming data. Windowing is one of those concepts that Roger mentioned. In-application streams is another. And we have support for at least once processing. So this means that we guarantee that we will always read and process each record and row in your stream at least once. And we will deliver that process data to your one of your configured destinations at least once. The final part is I have my SQL results and I'm happy with my SQL queries. Where do I send those results? So we support up to 4 unique destinations. That can be any combination of S3, an Amazon Redshift table, an Elasticsearch cluster, another Kinesis stream. This gives you the flexibility to do things like, I'm going to parse, validate, transform, filter my data, and then I'm going to send it to my S3 bucket. But there's a small piece of my data that I want to do analytics on in my Redshift cluster, and I'm going to go ahead and send it there. Or alternatively, it allows you to fan out for different S3 buckets. So you can do simple things like, for these record types, I would like them to go to this specific S3 bucket. For these record types, I'd like to go here. So it allows you that flexibility that we thought was important to include with the initial release, such that you can start organizing and analyzing your data. End-to-end processing speeds are as low as sub-second. So the example being of what I just gave, the streaming filter, you'll find that we'll read, process, and emit that data to a downstream destination in under 1 second. Other queries, like if you're doing windowed analytics, your processing speeds will be largely dependent on how large your windows are. So an example of a window is I'm going to compute an average over a particular column in my data over a 5-minute window. So in that particular case, you're aggregating for 5 minutes. We'll emit the result at the end of the window. So processing speeds will be 5 minutes in that case. One of the things of how we've implemented that we I've found customers have responded very well to is this separation of the processing, the storage, and the delivery. So Roger mentioned the aspect of composability. So the fact that you can write to a Firehose that is going to take care of that delivery to your destination for you. And if you have a downstream destination that has an issue, such as your Redshift cluster is running into problems, or your Elasticsearch cluster is having issues, we don't stop processing. We're continually processing the real-time data. If one of your destination goes down, the others are not going to be impacted, because the Firehose provides that nice buffer between you and that final destination. So what are the top use cases that you'll implement using Amazon Kinesis Analytics? So first and foremost are you building applications to perform time series analysis on your data. Some of the simplest examples of this are the one that I just gave, computing a 5-minute average over a particular column. So imagine you are ingesting application logs that have API errors in them, and you want to, over that sequence of events, calculate the percentage of errors in all API calls. That's something you can absolutely do using Kinesis Analytics. You can actually even do things more powerful, things like sessionization. This is event correlation across a sequence of events where you imagine a user is visiting your website or interacting with your mobile app, and you're correlating events by a user ID over a time sequence. So user visits your website, they click on a particular product, they click on product details, they add to cart. These windowing functions are all very easy to express in standard SQL. The other powerful thing about the service is we allow you to use independent windows on independent SQL queries. So for example, in the same application, you could be doing one time series analytic that's generating those 5-minute or 1-minute statistics. In the same exact application, you could be reading the same data and doing the sessionization or event correlation example that I just stated. Visualization is an important aspect of analytics. So we have several options that we're launching with. Some of them are near real time, and some of them are much closer to real time. But the reason why it's so important is because, as you guys know, you're performing SQL. A lot of algorithms and output of your SQL results is better interpreted through a visual representation. A key example of this is the anomaly detection function that we're shipping with. It generates an anomaly score, and it's much easier to tell where the anomalies are if you're visualizing the data. So we have several options for this. One of the options is the customers that we've spoken to so far implementing sort of operational use cases. Excuse me. Implementing operational use cases. They'll write to an Elasticsearch cluster, visualize that data using Kibana, using Amazon Kinesis Firehose. Data will be delivered in approximately 1 to 2 minutes, total end-to-end time painted on the screen in Kibana. Redshift is another great example. Hooking up with one of my favorite things to do as I interact with the service is to hook up Tableau or Amazon QuickSight to a Redshift table and to see those analytics come in on my stream in 1.5 minute, 2-minute latency. So again, near real-time latencies. For real-time use cases, the pattern what you'll do is you'll emit to another Kinesis stream with your analyzed data, and you'll write to the specific visualization or destination of your choice. This is something that we will definitely improve in the future, but you have a lot of options available to you right at launch. The third or final use case that usually comes up when we speak to customers is creating real-time alarms or notifications. So on your event stream and this sequence of events that you're processing, there are typically events of particular interest to you. And these could be computed analytics or they could be individual events. An example of an individual event is a customer running into an issue purchasing a product, or a customer running into a blocking issue using your mobile app. That is an individual event where you can search for using a where clause in which you want to either notify your ops team or you want to notify the customer, hey, we just found this event, we're looking into this. Alternatively, you can do real-time alarms and notifications using analytics. So this is, I'm computing the 1-minute average of the number of customers on my website, and if I have a very large drop based off an absolute threshold, I'd like to send that to CloudWatch Metrics or send that to SNS to put it into my monitoring solution. So the pattern for this is we'll read data off of a Kinesis stream or Firehose. We'll analyze the data using your configured SQL queries, emit to a Kinesis stream, and from there you can trigger a Lambda function, write to CloudWatch metrics. And really, you have the flexibility to enable this use case how you would want to, the composability that we keep mentioning. So SQL on streaming data. A lot of people are very familiar with writing SQL on a static data set. And they're introduced to it, they're interacting with MySQL databases or their data warehouse. And when you write SQL over a static data set, you get a deterministic result naturally. The data is not changing very, 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 very quickly. It looks at a snapshot of the data, executes the query, and gives you a result set. What if your data is updating continuously and needs to be processed very, very quickly? How do you write your SQL? So some SQL queries will operate naturally row by row. If you're selecting a particular set of columns, you have a where clause in that, it's going to look on those rows with your where clause to make judgments for your analytics. But when you're doing aggregations, things like averages, standard deviations, mins, max, you're looking at things across many rows. So what is the mechanism you use to bound your query? So these are important differences between SQL on streaming data and SQL on a static data set. So what does this query look like? So here I have a very, very simple streaming query. And you'll notice some things right away about it that look a little tiny bit different. So the first, we support SQL tables through the reference data that I mentioned. So how do we know that this is a streaming query versus a non-streaming query? The first is the keyword select stream. So we tell this is a streaming-based query. So our engine will determine that to operate it as such. We're selecting in that from clause a stream of tweets. These are the in-application streams that I've mentioned, which operate very, very similarly to a standard relational table. You select from these in-application streams, you insert into them, they appear in your from clause. But it looks very much like standard SQL with some very minor modifications. Each row has a corresponding special column called row time. This represents the processing time of, basically the processing time of your application. Every time we insert a row into that first in-application stream, we append a timestamp. This is one aspect of time that we support with our streaming analytics. We also support the ingest time of when the data was stored in the Kinesis stream or Kinesis Firehose and your own row time. So a streaming table is a stream. The way you build applications is that you'll create these in-application streams to store intermediate SQL results. The simplest application has two in-application streams. The first is correlated with your configured source. The second is configured with your correlated destination. And you're selecting from one in-application stream, inserting into another in-application stream, and we're taking everything that was inserted into that output in-application stream and sending it to your configured destination. However, you can build much richer, more sophisticated applications, almost complex event-like processing use cases, where you're doing things like 5, 6 steps in a serial pipeline, or alternatively, doing filters on your data and running different parallel pipelines, where you're creating an application stream, filtering off a portion of your data, and running a specific set of business logic for that subset of data. So I spoke briefly about writing queries on unbounded data sets. And how you do that is using windows. There are several different types of windows: tumbling windows, sliding windows, and custom windows that we support. What we're showing here is a sliding window. And you notice it does an aggregation. So I'm doing a count. So this query will operate across rows. So how do we define how to bound the query set? So the first thing I'm going to specify is a partition by statement. So if you've used Windows and Postgres, this looks really, really familiar, where you're just saying count author, partition by, count the number of authors, partition by author, where you're just going to group by the specific tweet author. So I'm tweeting, it'll group by myself, it'll group by our evangelist Jeff Barr, so on and so forth. The next is the time interval in which you would like to bound the start and end of your query. So here I have a 1 minute sliding window. The window starts as soon as you execute the query and update the application. And it will start emitting, it'll emit results anytime that window changes. So in the sliding windows, it's almost like looking at like a unit of sensitivity, how long the window is. You can also have row-based windows. So we mentioned I have a 1 minute window. You could also specify the last 1,000 rows, last 10,000 rows, that type of thing. So what are our different types of windows? So the first type of window that is using streaming analytics is, and perhaps the most easy to understand, is a tumbling window. This is useful for periodic reports in which over your specified window size, you want to emit a result at the end of that window. So when you're doing aggregations before you, to combine with historical data like in Redshift or S3, this is a very useful window. The window is always the same size, so it's a fixed size, and the windows don't overlap. So the start of the one window is the end of another. So when you're computing things like those 5-minute averages or counts and mins and maxes, this is very, very useful functionality. But what happens if you want to know what the result of a particular window is as soon as it changes? The example that I had in the last slide, the sliding window, is great for these use cases, and it's useful for real-time monitoring, for those real-time alerting and notification-like use cases. So the way sliding windows work is they're the same fixed size as a tumbling window, but they're continuously overlapping. Meaning that, since they're continuously overlapping, how do we determine when to emit a result? We emit a result anytime a new row enters the window and changes the result of the computation. So a simple example of what a sliding window looks like. Imagine a stream of events. You're writing 10 records to that stream of events per second. And your sliding window is 1 second long. And you're doing a count over that 1 second interval. So the way the sliding window will emit results, you'll execute it, and it'll start to build up state. So it'll be 1, 2, 3, 4, up to 10. At that point, it sort of reaches a steady state because you're writing to the stream at this constant interval of 10 records per second. And you'll start to see the sliding window emit results anytime a new row enters and exits the window. So it'll be 10, 11, 10, 9, 10, 11, so on and so forth. So not every one of those data points is useful, but when you combine with like a very simple where clause on an absolute threshold, you just set up a super powerful application monitoring query. So sliding windows are very, very useful in that regard. And one great thing about how we've implemented the SQL here is that you can have independent windows in the same SQL query over different metrics. So for example, if you want to do an average over a particular metric over a 1 minute window, but you want to do the max over a 10-minute window, you can do so in the same exact query. The final window is what I think is one of the most valuable windows, but it is definitely one of the most difficult to understand. And these are called, I'm offering a fairly ambiguous term to describe them. They're called custom windows. The reason why I call them custom windows is because the start and end of the window are not defined when you execute the SQL query. You're looking for particular conditions to start the window and end the window. So an example of a custom window is the sessionization example that I brought up. So I want to start a window anytime a new user logs into my app, anytime a new EC2 instance starts up. And I want to track that over a particular time interval, looking for particular events. So I'm starting up an EC2 instance. I want to make sure that it successfully started up and my application was bootstrapped and is running effectively. And I want to do that to make sure that it occurs over 10 minutes. So I'll end the window if I see that I have a status notifying me that my application is up and running correctly. And if 10 minutes passes and that occurs, I'll emit a result. These are custom windows. And you can see when you have the ability to provide such flexible windowing, you can enable fairly powerful use cases. So what are the patterns with how you'll implement your applications? What have we seen customers do from our conversations with them? There's usually a couple steps. So the first step is the pre-processing step. This is, I've initially received the data into my application, and I need to transform it, manipulate it. It's sort of like that initial ETL step to get it to be the nice, clean data that I want to work with in my application. So we take care of a part of this for you with that initial schema inference and applying your initial schema that you specify. But a lot of times people want to do more. They'll filter it. We've seen some interesting cases where customers are combining different data formats, like they've combined with JSON and CSV. So for example, they have a column in their, or a key value pair in their JSON document, which is a CSV record, and they need to do additional splits. Or they have a column in their data structure that is very, very unstructured, and they need to rip out specific values. They have an application log that they're processing, and they almost want to like annotate it and tag it. So they've put in a raw column that is your like Apache log, and it's a column of type varchar 5000 or something like that. And they want to search for particular patterns in the Apache log and start adding columns, saying like, this was an error. This was an error of type blah, blah, blah. This was a specific application. These are these pre-processing steps sort of to get more information, to understand the data a little bit more. These are usually the first queries that you write. And you write that query, you select from your source in an application stream, you insert it into your first intermediate in application stream. The next queries that people typically implement are the basic analytics. So simple counts, simple aggregations over the windows that we've discussed, where they're taking that cleaned up data and they're just performing that basic analytics. And those two use cases, just getting from the pre-processing step and the basic analytics, when I go through the video in a couple minutes here, you'll see it's very quick getting to that. So I think that's why we find the service, customers have tried the service out, found it so easy to use. And then finally, it's the advanced analytics, where you start getting that value from your data and reacting to that data in real time to really sort of take your data from just being data to transforming it to information to finally getting to insight. We support things like the event correlation use case sessionization that I brought up. We also have our anomaly detection algorithm, which will basically, you'll pass it a set of numerical data points, and we'll send you back an anomaly score that's almost like the likelihood it's an anomaly. So you can find outliers on your data stream. You can also do advanced analytics that things like filtering a particular set of data or a particular event type off of your stream, inserting it into an application stream, taking a different event type, inserting into a parallel in application stream, and then merging those two streams together. So this is that complex event processing use case that I kept bringing up, where you're almost looking at these in-application streams as nodes in your processing pipeline, in its processing steps. Finally, the post-processing steps. Sometimes this is needed. It's not always the case. They're usually needed on like alerting or triggering like use cases. So you might have a bunch of analytics computed in your stream, but you may only want to send to your real-time notification service when particular events occur. These are the last steps. They're typically simple where clauses. They can be more complicated though. You could use, for example, you could be computing tumbling windows in combination with sliding windows to figure out what to emit to that downstream destination. But it's usually your last query, your last SQL statement before you insert into that output in an application stream and the data flows downstream. So how do we charge you for this service? What is the pricing model? We have our unit of scalability and our unit of processing is called the Kinesis processing unit. And it's fairly simple to understand. It represents a single vBCU and 4 gigabytes of memory. We will scale the number of KPUs for you based off of two things that primarily drive what your compute and your memory usage. The first is fairly obvious. It's the data throughput on your stream. So just reading from that stream, processing it, getting into the SQL engine is very different KPUs of if you're processing 1 record a second versus 100,000 records per second or rows per second. The next is your query complexity. So example being different types of queries will use different types of resources. So if you have a lot of windows in your application that hold a lot of state, that will be a more memory intensive application. And we'll scale the number of KPUs for you such to match your memory requirements. Alternatively, if you're not holding a lot of state, but you're doing a lot of streaming filters and you're processing a high throughput of small records, these are typically CPU-bound workloads. Well, again, we'll scale the number of KPUs for you so that you don't have to choose an instance size to try to match the requirements of your application. I'm not sure if I'm actually hitting this to skip the slide over or whether it's just triggering itself. But I apologize. So the KPU is 11 cents per hour in US East 1. We're launching in 3 regions today: Northern Virginia, Oregon, and Dublin. So though it's simple to understand a KPU, we recognize that it can be sometimes challenging to figure out, well, how much am I going to spend? How much is the throughput? So what we'll typically recommend, we'll give you visibility to it in the form of CloudWatch metrics. And over time, we'll give you more and more transparency. Like definitely from talking with the customers, we realized that we got to give more transparency over time on this. But just to give you simple examples of what this looks like. So a single KPU, you're processing processing about 1 megabyte or 1,000 records per second on your stream. So a small to medium sized workload. It's cost $80 a month, so a single KPU to do a bunch of these streaming filters use cases that I mentioned. Another use case is I'm doing aggregations over 1 minute windows on a stream 5 times the size. So let's just say I have a 5 megabyte per stream per second streaming data source, and I have a bunch of 200 byte records flowing through it, so a bunch of very small records. So I'm having to hold a lot of state in my window. I need 2 KPUs, it'll cost $150 a month. We found from our initial conversations with customers that the elasticity of this model is what they truly appreciate, because it's very hard to anticipate peak loads and how a customer's query is going to respond when the data changes with a different variety over time. So the final slide that I have is we're going to go through a walkthrough of creating your first Kinesis Analytics application. And I really encourage everyone in the room to try it because it takes 5 minutes. It's very, very easy. So I provide a name to my application. So this will be my first Amazon Kinesis Analytics application. And then from there, I'm taken to the application hub page. The 3 components of the service that we keep mentioning are presented on that page: the source, the application code, and the destination. I'm presented with a list of my Kinesis streams and Firehoses. And I have a demo stream which is available to all of you to try the service out, which has simulated stock data inserted into it directly from your console. We go through a process called discovery, infer the schema, and present it back to you, and show it to you in a very familiar tabular format. From there, you can view the raw data records that we sampled off the stream, as well as edit the schema to your liking, to either restrict it farther or unrestrict it. So on the top part of the screen, you see your columns laid out, the JSON path, which points to the specific element in the JSON document, the data type, and the parameters around the data type. On the bottom half of the screen, you see your data stream. I'm going to start the application right now, and I'm going to start at that point, you can start schematizing the live data stream. This is very helpful for test and development, where you can see different data flowing in. I'm adjusting my schema to accommodate that different data. We recommend you define schemas that are fairly flexible. If data comes in that doesn't conform to your schema, we send to what's called an in-application error stream, where you can select from that in-application stream, but in most cases, customers will just select everything from it and insert into an S3 bucket. This was a malformed record, this didn't apply to my schema, send it here. This is our interactive SQL editor. On the top half of the screen, you have a text editor with intelligent autocomplete, find and replace, syntax highlighting. On the bottom half of the screen is where your SQL results will be shown, as well as there's some data exploration features in it. And then we have a nice feature that allows people to get started easily called SQL templates. Here's a couple that we've launched with. We are excited to work with customers and add them over time. If you find something useful, send it to us. We'll add it to the templates list. You can see we have continuous filters, aggregations over different types of windows, simple alerting queries. All of these templates work with the demo stream that I already selected as my streaming data source. I'm going to click Save and Run, and you're going to see the SQL queries right in your browser in real time. We idempotently update the application, checkpoint, update the SQL code, and then present the SQL results back to you. On the left-hand side of the screen, any in-application stream that you create, you have the ability to get visibility into. So you have a 6-step pipeline. You can see the results of every single intermediate step. It gives you great visibility to what's happening into your stream in real time on the console. I'm going to select another query here. The query I'm going to select is an aggregation over a tumbling window. It's going to do a count over 10 seconds. So you'll see that special column that I mentioned, row time, iterating every 10 seconds, computing those counts. It's going to group by this ticker symbol. So you'll see the number of transactions on the simulated stock data stream per ticker symbol come out every 10 seconds. So this query takes 10 seconds, so I'm going to pause. We mentioned the processing speeds. This is reflective of that. The continuous filter operates sub-second. The tumbling window that's 10 seconds long, you're waiting 10 seconds for every result because it's emitting results at the end of every window. We'll continuously stream sample data to your browser so you can get visibility to whether your query was correct. When you're happy with your query result, what you'll do is you'll create a destination and you'll basically point to the in-application stream that you created that you want to emit downstream. So in this case, I have a destination SQL stream that has those aggregated results. I'm going to choose my output format, CSV. And I'm going to choose a Firehose delivery stream, which is going to emit my data to and automatically load it into Redshift. From there, you've got an end-to-end running application. Hopefully this is not the end of the video. Yeah, an end-to-end running application that is continuously reading data from your streaming data source, processing that data using your SQL code, and emitting it downstream. So you basically have a fully managed application that's elastic, that's performing your analytics. And there we go. Looks like it's a little bit too long to save there. So there's your completed application. So that is the end of my talk. I'm happy. Thank you very much for attending. We're really excited to see what customers will build with this service. We think that we've just started here, and we're very encouraged with what you guys will do with the service, listening to your feedback, and continue to build out the service to meet your guys' needs. The other thing that we find very valuable is that we now have an end-to-end streaming data services that consist of streaming capture and allowing you to build custom applications through Kinesis streams, ingestion and loading of streaming data at a high velocity that's scalable with zero administration with Kinesis Firehose, and a powerful SQL-based streaming data application service that allows you to attach to both Kinesis streams and Firehose, continuously process that data and emit it to downstream destinations of your choice. So I'm going to stay. I'm happy to answer some questions. Thank you guys all very much for attending. If you could just come up to the microphone, or if you don't mind speaking up.
Okay. So what is the reliability of these streams? So if I have a window for, say, 3 hours and my machine goes off?
So the question is, what is the reliability of the service if I have a 3-hour window? What happens if the stream goes out?
Yes.
So the Kinesis streams, Kinesis Firehose are durable storage services, all right? So they guarantee no data loss, all right? Kinesis Analytics, we do all of our processing in memory, and we take checkpoints throughout the application. which are basically like watermarks of where in the stream have we read and processed data successfully. We then have at least once processing semantics, so when we've successfully delivered your data to your destination, we'll checkpoint and say we've successfully processed all records for this destination from the streaming data source. Regarding the size of windows, this is a real-time streaming application service. We typically won't recommend you having more than, say, an hour-long window. There are certain very specific use cases where you'll want to compute longer windows on. I'd love to have a conversation about those specific use cases, but if you're doing a 3-hour-long window, typically it's easier just to compute what you need to compute and get it into a downstream analytics.
No, we usually have a few second window.
Yes.
I have been using Stream SQL.
Yeah.
But obviously we don't want to lose data in between just in case.
Yes.
It processed 4 seconds, and the 5th second the data is not there because.
I understand. So we read data from a very durable source, and we take checkpoints as we process it. Does that answer your question?
Yes.
All right, great.
Thank you so much. This is very, very helpful, and I'm very excited
Thank you.
about what you got. So the question is really, you've got a fully compliant ANSI SQL interface. As far as the roadmap is concerned, do you see the ability for other applications to write SQL against this, or will it be really just you write the SQL there and land it within ESB and
I got you.
Yeah.
It's an excellent question. So the question is, you can write ANSI standard SQL over streaming data with Kinesis Analytics. Do you see the ability of other applications to basically tap into the application and write their own SQL on the structures we're creating? We're learning from our customers every day. I can say that what you just described is something that has come up quite a bit since we've talked to our customers. We do have APIs. The entire console experience is backed by APIs in which you can update the SQL. To get the SQL results, you really need to send it to like a Kinesis streamer or a Firehose though. But that being said, like future state,
Yeah.
the only thing I can say about that is that we've heard that request, like, can you guys offer a JDBC connection or something like that?
I was about to say JDBC
Yes.
or ODBC because, quite frankly, most of the data, deal with machine. It's 5 to 10 seconds, and most of it you're going to throw away.
Great question. We're going to listen to the feedback we get over the next couple of months,
Yeah.
but I realize that that's already at the top of mind for us.
Yep.
All right.
Okay. Thank you.
Hi.
Great stuff. So the formats, I have a question about formats. Support JSON, delimiter, text.
Yes.
Is this extendable? So we have a lot of data flowing through Kinesis in Avro format. Is this extendable to?
Unfortunately not right now. When we've talked to customers, Avro comes up quite a bit. I mean, the speaker before us is Comcast. We've been working with them quite a bit, and they also use Avro. Mm-hmm. This is absolutely on our radar. Avro specifically is on our radar because we've heard it a lot from customers. I think what you just described, though, is where we'd like to think about the service, where we make a couple things super easy to use, like JSON or CSV, possibly Avro, and then make it extensible after that. Because when we've spoken to customers, it's not just Avro they bring up Avro, Protobuf, Amazon Ion, all sorts of different serializable format. And we're curious to hear from customers what they need. If it's just support Avro, we'll just do that. If it's run a piece of Python code or something like that before to transform the record, we'll do that.
Well, I think the important thing is that it's extendable, more so than just say support Avro.
Yes.
Because who knows, 2 years we might not have Avro anyway. So the extendability is the most important piece. Is there any immediate plans about that, or what's that in the roadmap?
All I can say is that we're really excited to release this to the public right now. We've gotten some initial feedback from customers that we've been working with over the last couple of months. I think I've shared that Avro is an important part of that feedback, but I can't really say when we're going to get to implement a specific format or an extensibility. I will say that I agree with your conclusion about it's more important to be extensible than it is to support and 50 million formats.
Great.
Thank you very much for the question.
Hi, very informative session. I had a question about the anomaly detection.
Yes.
What kind of machine learning algorithm are you using, and is there a roadmap for any of evolution of that?
So the question is, what type of algorithm does the machine learning online anomaly detection algorithm implement? Thank you for asking that question. I really like to geek out on some of this stuff, so I appreciate it. We have a principal machine learning scientist. Her name is Nina Mishra. She just attended the ICML conference, and there's a published paper that we have on our websites where you can read all about the algorithm. We're really excited about it because some of the internal teams have been playing around with it, and they find it works really well. I think our approach is to make a couple of these algorithms super simple and then get feedback and see, like, do you guys want extensions? Do you want other couple of simple algorithms? But I think in order to read more, the paper's on our website. It's also on the ICML website.
Thank you.
ICL, I actually forget what the acronym stands for. I apologize.
Hey there, yeah, it looks like a super interesting product. A very basic question. It was hard to tell whether each stream could output into just one destination, or if you could have multiple destinations and you could dynamically sort things out into different destinations. For example, if I had an incoming stream and I wanted to like dump stuff into different Redshift tables, like dynamically, is that doable or?
Absolutely. So the question is, it's hard to tell whether I can like read from a single stream and then just fan out to different specific destinations. Absolutely supported. For example, you could write to what we think one of the most common applications is going to be is I've got 5 record types in my source stream, or 10 records type in my source stream. I filter off into separate application streams for each record type. I do a specific analytic like aggregation on that, and then I write to a specific Redshift table. That is absolutely supported. We support up to 4 destinations
like
at
4
launch.
tables?
So the way we write to Redshift, and the way right now we write to most destinations is through a Kinesis Firehose. So each Firehose is tied to a single Redshift table.
Right.
So it'll load up to 4 different tables. And then Redshift, Firehose itself is looking at interesting functionality down the pipeline to also do more of that. So I look forward to the end of, towards the end of the year, okay?
Right, yeah, my question was, yeah. I'm really looking forward to that part because we have an unbounded number of dynamic tables that we're doing.
So for launch, for like right now, what I'd recommend is just, I mean, the processing latency when you're doing filters is really, really fast. So what I'd recommend is just doing app, this is a bit of a workaround, so I'm gonna admit it before, but what I recommend is just to do like app, stream or Firehose app, and then just continue to fan out to get to the number of destinations that you need to. Each one of these solutions is fully managed, so, but I do recognize that keeping track of it is a little bit of a pain, so we can always improve in the future there. But that's how I would approach that problem for now.
Awesome, thank you. It looks awesome.
Thank you, I appreciate it. Hi.
I think you kind of answered this, but when you define the schema, that wasn't stream specific, that was query specific.
No, it is stream specific. So we have one schema per streaming data source that's added. We support a single streaming data source, and therefore we support a single schema. We have gotten some feedback that customers want us to like support multiple schema for different record types. But sorry, go ahead.
Yeah, because you said that you could have different events going into the same table and then go to different sources. Wouldn't each of those events have their own schema?
So the discovery, the schema inference, does a really good job. Like if you have 30 different record types, and they have 10 columns each, so you have 300 columns, it does a really good job. If it reads 30 different record types, it'll just recommend a normalized schema. Each column is not nullable, and you just basically use a determinator to filter off after that point. So it's basically flatten everything into a normalized schema and then filter off. And I do recognize that certain situations makes that a little bit difficult. Is there any way that you think that we could improve that? Like, how would you like to run?
It kind of back to what he was saying, I actually work with him, was like we have a bunch of different type of events going onto the stream, and then we want to be able to filter on them and say, this is this event type, go to that Redshift table. So if each of those event type could have this defined schema, and then boom, go to your Redshift table.
So the approach that I mentioned is how we're going to take it for now. Again, is how we're going to approach this for now. So just define a normalized schema. You'll have a bunch of sparse columns for certain records.
Got it.
And what we are really curious is for customers to try this out with the different data in our streams now that it's out publicly, and then give us feedback on it. I mean, if you have, the approach that I just recommended, if you have like 300 different record types and 100 columns on each record type, it's not going to work real well. So, but I'm curious, we think that we've solved the majority of the problem for most customers, and we're looking forward to just iterating on what we currently have to meet like use cases like you just specified.
Thank you.
You're welcome.
Can we use this with XML data?
No, unfortunately, we do not support XML. Is that an important use case for you?
Yes.
It is? Yeah. Do you have XML data that's currently flowing through your Kinesis streams or Firehoses right now?
Yes.
Okay.
It comes to Kinesis stream. And one more thing what we do is like some part of data is encrypted.
Okay. So we don't, the XML, if you would stay just after the session, I'll give you my business card. I'd love to follow up with you specifically on it because it's something that we've already spent some time thinking about it.
Sure.
Around the
the
decryption or encryption or unbatching. Right now, your data has got to be UTF and encoded. So if you've worked with a specific, what we recommend now to customers, and we'll listen and we'll improve upon the experience when we launch, is to basically have some Lambda function or a simple KCL app, just reading off of your source stream and simplifying the data basically, and then inserting into another Kinesis stream, and then running Kinesis analytics on that. We got the question about Avro earlier. One of the gentlemen asked about Avro. We have a customer that has Avro data, and that's basically what they're doing. They have a Kinesis stream. They're already using Lambda with it, but they want to do more powerful analytics in real time. So they're processing that data. They're reading from the source stream, changing the data to standard JSON, and then writing to a Kinesis stream. Our team fully recognizes that that's a workaround, and we'll improve it in the future. You could do something similar for XML, but if you stay around, I'd love to talk to you a little bit longer about it. Thank you all very much for attending. I really appreciate it.